Hi all, I think we're live.
So we are live. Thank you very much who came to this broadcast. We're glad to see you all. This is the first um, guest talk event that we conduct in the new semester at Nazarbayev University of GDSC chapter. So my name is Madiyar. I'm new GDSC lead here at Nazarbayev University. Today we will welcome Aritra Roy Gosthipaty and Askar Aituov. So Aritra is the deep learning associate at PyImage Search, renowned Keras expert in the field of machine learning, who will share today his background knowledge in machine learning and deep learning, and he will share some important information and knowledge about the Keras that he prepared in his presentation. Also, we welcome Askar Aituov as the guest speaker here today at our session, who is the regional coordinator of Google Developer Student Club initiatives in Kazakhstan, Central Asia, and Turkey. So welcome, Aritra. Welcome, Askar.
Thank you so much for having me.
Hi all.
So I guess we will start by the presentation that our guest speaker prepared. So let me share the screen.
Madiyar, can I just tell a couple of words to our viewers? Meanwhile, the deck is being loaded. Unfortunately, I couldn't join on the studio from Nazarbayev University because we have Google for Startups Silkway Accelerator jointly with Astana Hub launch today in the same city in Astana. But next time, hopefully, we'll do some offline in-person event at Nazarbayev University. Congratulations to Madiyar with continuing the tradition of this club. It was the champion of actually global top 10 of Solution Challenge this year. First time in history of Central Asia team got to the winning league, and it's from Nazarbayev University jointly with Keras. And to those viewing in video recording, if you're a student, you can lead or create a student club at your university. If you're a professional, you can lead or join a GTG chapter for professionals in your city. If you're a woman, we have woman tech maker programs, and also for startups, we have dedicated program for startups, as well as cloud learning programs and my Droid. We have actually lots of learning and networking programs. Feel free to join. And thank you so much, Aritra, again for investing time to this event. Invaluable contributor to Keras, a great team, and it's actually the I think cutting edge technologies these days. Thank you, Madiyar, for organizing this. Good luck, everybody.
Thank you very much, Askar. So let me share these slides.
I think there is. I'm also sharing my presentation screen. Could you load that up instead? Because that's the slide that I'm trying to get up to.
You want to share your screen?
Yes. That's the slides that I'm trying to get up to. Yes.
Okay. 1 minute.
Not an issue. Yes, that's the one. Thank you so much for doing this. Can I start?
Yes, of course. Thank
Cool.
you.
So thanks for having me. I'm really excited to be giving this talk. This is the first time that I'm giving an online talk on the Keras philosophy, which is very close to me. And as you can see that it's not only me who has invested in this presentation slide, it's also my colleague and good friend Ritik Raha, who is unfortunately not here with me presenting the slide, but that's about it. So what we did once we were talking about how to present the Keras philosophy. So what is Keras? Why we need Keras? How to Keras? we kind of divided the entire talk into two portions. One which Ritik was going to take, one which I was going to take due to his absence. Both of them are going to be taken by me. And before I begin with what I'm trying to convey in this talk, is that it's going to be a long hour. So I beg your pardon for that. I'm trying to make an intuitive sense of why we need Keras and what is Keras. So in that, I'm trying to go into a journey of deep learning, why deep learning is how it is, what are the mathematical intuitions that you can build out of deep learning, and then we start with Keras. So that's something which you can expect from this talk. Now, I also am a deep learning associate at PyMedSearch, and PyMedSearch is an education company, a tech company, which focuses mainly on deep learning, machine learning, computer vision. So if you want to get down into beginning your deep learning journey, just scan this QR code and you will be good to go. And to start things off, simple things should be simple and complex things should be possible is a quote by none other than Francois Chollet, who is the creator of Keras. And this is one of my favorite quotes. And to start off with any deep learning project for that matter, and not only slides. This means that a platform or an API or maybe just a project should be simple enough to be understandable, to be intuited. And even if it's too simple, the complex concepts should be possible and not complex enough to not be understandable. Why do we need deep learning, and why do you go into the realms of machine learning and deep learning is some subject that I think everybody is familiar with, hence you are invested in this talk. What I'll cover is what is deep learning. So in a basic one-liner, deep learning is just matrix manipulations. So you have y, which is going to be a function of your x. So y being a label or a prediction depends on x being an input. And the bunch of symbols that you see, if I bring up the laser, and the bunch of symbols that you see like W1, W2, B1, and B2 are called parameters of your model. So these parameters are nothing but your weights, that is W1, W2, and biases, that are B1 and B2. And this small function, that is a sigma function, denotes a non-linearity. And it's as simple as that. The entire deep learning framework can be kind of compressed into these weights and biases and matrix manipulation. So now that you are familiar with what we are going to cover, we can also write code to signify the entire equation. So y is equals to W1 nonlinearity W2 nonlinearity W1x plus B1 and B2. It sounds and seems a little intimidating, but once you have code laid out where x is a random variable, W1 and B1 are weights and biases, which are also random for now. B2 and W2 are again random for now. And we basically write out this entire mathematical equation in terms of a TensorFlow code, And why did I bring up this slide is to bridge the gap between maths and code. So once you understand the math behind deep learning, you can quite easily bring that up to code, right? And now that you understand that you can code the entire equation, deep learning does not only stop there. Deep learning also talks about these W1, B1, that is weights and bias, W2, B2, again weights and biases, are updatable. So these are not constants that you always have lying around. You have to update weights and biases in order for your model to quote unquote learn. That is what we know. So a really easy example is you have an image and you have a model which classifies whether this image has a dog or a cat inside of it. Now, with a model which is randomly initialized, as you can see, W1, B1 are random normal. So it's randomly initialized, right? It does not know whether the image, once it gets into this model, is going to correctly classify the image into being a dog or a cat. Now you have to update the model so many times and in a proper way so that once you have an image of a cat, the labels tell you or the predictions tell you that, hey, this image is of a cat and not a dog. So you have to understand how this learning process comes into play. And what best way can you update these weights and biases in order for your model to learn? That is where your gradients or calculus comes in. So think about whatever I have told you right now. So you have an image. An image consists of a cat. The image is fed into a model, a classification model, and the classification model has this one thing to do. Its job is to classify whether this image has a dog or a cat. So it's an image classification model. Now, once you have a prediction saying that the image contains, say, 90%, it's 90% confident that it has a cat, right? Or it can also say that it's 90% confident that it has a dog. So you have this error that comes up with your model, right? You have this loss that comes up. So most of the times your predictions are going to be skewed or maybe wrong or maybe correct. You have to understand, you have to have a metric that lets you know whether the model is doing good or bad. Now, once your model is doing bad, you have a large loss. Once your model is doing good, losses go down. That is the entire metric that we are going to concentrate on. Now, what do we need in order to update these weights and biases? Is the gradient of the loss with respect to the weights. This factor tells you how sensitive is the loss to each of these parameters, each of these weights, each of these biases. So if you change weights to, say, from 0.1 to 0.2, does the loss change drastically, or the losses don't change at all? And now that you have this information of the gradients or maybe of these gradient terms, for a lack of a better term, what you now know is that which of these terms, which of these weights, which of these biases do you need to tune more, which of these biases or weights you have to tune less. That means if you have a weight that drastically shoots the loss, way up, you need to know that the weights have to be tuned very, very properly so that the losses go down. But you also have a weight which has no effect on the loss. The gradient is zero. That is DLDW is zero. You know that your weights, whatever change you make to these weights, they are not going to affect your loss. We just don't change the weights, right? So that is how you kind of intuit how to update your weights and biases. And why do I go into a lot of these depth words like gradients? Why do you need updates? Because you need to understand that there is a concept of automatic differentiation that comes into play right now. So in my slides, what I did cover is y is equals to an equation which is based on the input, that is x. And you also have these parameters, that is weights and biases, that you have to update with the help of your gradients, right? Now, as deep learning engineers, do you want to sit with your notebook and a pen and derive the entire weights and biases and all the differentiation with hand? I guess not. And that is where these automatic differentiation engines come into play. So TensorFlow has its gradient tape. There is also a gradient API on PyTorch. There is also a grad API with JAX. And all of these have this one single thing to do. It helps you find the gradients of the loss with respect to the parameters that you are trying to build. So you don't have to read the entire equation, figure out what goes where, and build the entire graph on your own. So it saves time, and it's also code efficient, right? So think about the entire overview of what we need as deep learning engineers. And we also have entire course on automatic differentiation at PyImage Search. It's just a segue into a blog post, which is free of cost. Just get into if you want to understand the nitty-gritties of automatic differentiation. But that is not what we are trying to do today. What I'm trying to say is deep learning is this matrix manipulation and weight updation and gradients. These are the three main blocks that you need to understand deep learning. Where does Keras fit in? Keras fits in to be a user interface for deep learning. What do I mean by user interface? And I'm sure everybody knows what a backend engineer, what a user UI engineer is. What I'm trying to say is Keras is a user interface for deep learning operations. It's not TensorFlow, which has an automatic gradient engine. It's not PyTorch, which has an automatic differentiation engine on its own. It's not JAX. It harnesses all of these automatic differentiation engines, and it just helps you as a deep learning engineer to make your models, compile your models, train your models as quickly as possible. So Keras is a UI for DL, right? And once you understand what Keras is, I will also help you understand how you work with the Keras workflow. So in the next 10 slides, what I'm trying to cover is a template of what you need as a Keras, as somebody who is beginning with Keras, or maybe somebody who already knows what Keras is to get quickly up and running with your deep learning pipeline. So these are the steps I'm going to cover. And one by one, the first one would be the necessary import. So you import something into your machine, into your collab notebook or whatever, where you're trying to iterate on the model. So import TensorFlow as TF, import Keras. These are the two things that we need primarily. TensorFlow, because automatic differentiation package is not present in Keras. We have to harness this automatic differentiation engine from TensorFlow, but Keras helps you run on top of that. Data pipeline, data is important, right? As deep learning engineers, we are trying to model on the distribution of the data that we get. So say, for example, a bunch of images, data, a bunch of text corpus, data, a bunch of images and text, multimodal data, and all of that stuff. And with TensorFlow, what you also can harness is the tf.data API, which is very efficient. It helps you shuffle your data, batch your data, map your data into different functions and whatnot. And that is how you create this entire data pipeline, which helps you feed data into your pipeline, and the pipeline outputs something in numbers that the model can ingest. So think about it, a big pipe wherein you feed data from the top, it gives you numbers from the bottom, and these numbers are something that you are going to feed into your model, right? So imports, data pipeline. Next is model construction. You need this model on which you're going to iterate and make your training workflows easier. You want to build or learn your model, right? And this is where the term model or weights and biases come in. So think about model to be just a box with a lot of parameters being your weights and biases. Remember the ones that we updated quite a few slides back. These weights and biases are the ones which are inside of this model. Now you have many ways in which Keras helps you construct models. I'm not going into too much right now. We will cover the different ways, but just think about models to be a box of lots of weights and biases. And once you give data, once you have a loss, once you have also harnessed the backpropagation algorithm, your weights and biases are going to iterate and get better, and the model is going to learn the data more and more and more, right? So that is our entire goal for the time being. Once you have this model constructed, you also need to tell the model on what or the metrics that you need your model to learn. So the first is going to be the optimizer. So the optimizer is going to tell you which optimizer that or optimization algorithm or optimization strategy are you going to use to update your model. So there are a bunch of optimizers like ADAM, like stochastic gradient descent or SGD, like RMS prop, and bunch of others that are present in the Keras ecosystem itself. So try it out for yourself and understand which optimizer does what in order for you to understand what your training pipeline needs to look like. The loss is important because the loss is the term that we are trying to minimize. So it might be an L1 loss, it might be an L2 loss, it might be a different loss altogether. You might build your own loss and publish a paper, and I might be the one who is trying to reproduce your work. So there are a bunch of losses again in the Keras ecosystem. And there are also terms called metrics, which help you understand how your validation is going to go. So, like I told you, the example of cats and dogs. So the input getting into the model, and the prediction comes out of the model, and the model tells you that, hey, this image has a 90% probability that it's from a cat, right? And once you train your model, you see that these metrics, as in the prediction being good or bad, are going to go better. So you also need to track your metrics, not only the loss. Now comes the crux of entire deep learning paradigm, or the entire deep learning pipeline, is model training. You have your data pipeline well and set. You have your model constructed. You also have your model compiled with the optimization strategy that we are going to take, the loss we are going to take, and blah, blah, blah. And you do a model.fit. What does this mean? This means that now it's time for your model to really get these numbers in and train the weights and biases. So the model.fit term is only used when you're going to train your model. You have to specify X, that is the input, Y, that is the labels. Now there are concepts like supervised learning, unsupervised learning, semi-supervised learning. In this talk, I am only focusing on supervised learning, where you already have the ground truth of the image. So you have supervision. You can tell your model, hey, you are wrong or you are right. Thanks to you, I can train the model better. So why is these target labels? And epochs, the epoch term turns out to be how many steps are you going to iterate this model on. So it's not just one single shot that your model is going to train, right? You have to iterate the model with a bunch of new data, augmented data, and whatnot, and the model is going to learn slowly. And there are also concepts like callbacks. I'll come to callbacks a little later, but the essence is callbacks are friendly functions that you can call back inside of your training loop, right? If that does not make sense, don't fret. I'm going to cover it a little later. Model inference is important because once you have your model trained, that means your model can, with an accuracy of say 95%, it can say whether your image has a cat or a dog. It needs to infer on absolutely untrained or images that were not trained on, right? It needs to be efficient with test images. That is something which it does not has not seen yet. So model.predict kind of tells you that, hey, you have given me this image, it is indeed of a cat. And with this model, what you can do is you can create a website wherein people can post their images, and just for a fun project, you can tell them whether the image is indeed of a cat or a dog. So you can infer on the model. That is what I'm trying to make a point here. After you understand how the template is, now let's call back to the title of this talk, which is Understanding the Keras Philosophy. The Keras philosophy is very simple. It's simple, flexible, and powerful. Keras should make your life simple, should make your life a little flexible, and it also should give you tools which makes you think that you are powerful. Not only think, but also will make you powerful. That's my guarantee. Why did I say this? Because simple comes from the Keras sequential API. This is an API which helps you build your model in a very easy and flowy way. I'm going to cover the code a little later. Functional API gives you a little flexibility as to if you don't have a model that just takes images, you also have models that takes images and text. So functional API can help you with that. It can give you a little flexibility to how you model your entire workflow. And model subclassing is the third type, which gives you power. That means if you, for some matter, you don't have a very easy to look at code or a research paper that you're trying to reproduce, or maybe something that you are trying to build on your own, in a matter where the internals or the working of the model is something which is very different to what normal deep learning paradigms do, you can subclass your model and construct the entire training loop from scratch with TensorFlow and Keras. So you don't have to think, hey, I don't have this module. Say you are talking about a convolutional neural net or maybe multi-head attention or whatever. You don't have this in Keras. Can I still build it? Of course you can. You can always subclass your model and build the entire training module from scratch. Everything works off the bat. You can also use the model.fit API to fit your entire model uh, inside of the training paradigm. So that helps you. And why not we talk about sequential, functional, and subclassing a little more. Sequential is as simple as this. So you have a dense layer, and you pack both the dense layers into a list, and you pass that list of layers into a sequential API, that is keras.sequential. And Keras understands that, hey, the person who is trying to give me a list of dense needs a model which has just 2 layers of dense modules. And that's it. Your entire model is built. You can just do a model.compile with your optimization strategy, and you can do a model.fit, and it works off the bat. It's easy, right? Now comes to the functional part, which makes it a little flexible, your life a little flexible. So here what we do is, we have a keras.input. This is also a layer of Keras. The input layer goes into dense, and the output of this dense layer is X. The X goes into another dense. And now you can create a model with the inputs and outputs. It does not need to understand what goes where, which layer is used after what. It's like an acyclic graph that you kind of build in this cell. And right at the end, you just have to mention what are the inputs, what are the outputs, everything works fine. So think about your sequential API. Sequential APIs, you do have to mention the layers one after the other. But in functional, you don't have to mention anything one after the other. You just have to mention an inputs, you have to mention the outputs. And in the inside of inputs and outputs, you just have to name a bunch of layers and also provide which outputs goes where, inputs goes where, and just call keras.model with inputs and outputs. The model will be constructed. That's good. Thanks, Aritra. That really helps. But what if I need a layer or a model completely from scratch? I don't need something called keras.layers.dense. I don't need something called keras.layers.conv2d. Fret not, Keras has your back. So the first thing is layer subclassing that I'm going to touch upon. So layer consists of weights and biases. So going back to our old days, and y is equals to mx plus c, which is the equation of a line. And if you just replace m with w, that is weights, and c or the intercept with b, that is bias, you have a linear layer that you have constructed fully from scratch in Keras. And this can work in any workflow that you have to add. So w is a weight, b is another weight. You just have to mention the shape. You also have to tell whether it's trainable or not, because you want your layers to learn. So I have kept it as true. If you don't want it to learn, keep it as false. Not an issue. And in call, you just have to mention the equation. So tf.matmul is basically matrix multiplication. So matmul of inputs that comes in with the weights and add it with biases. So this w is equals to y is equals to wx plus b can be a layer in just how many lines? 10 lines of code. You're good to go. And this is another template of a layer. So here you have these weights and biases, and here you have the call. You enter your states or enter your parameters here, enter your computation, and you're good to go with your manual implementation of a linear layer. And now comes a model subclassing. So I think I'm sure with people who are currently viewing this that they know the difference between model and a layer. A layer is a single abstraction which contains of weights and biases, but a model is a container which contains a lot of layers. That's the only simple difference between these two. So like you can also subclass layers, you can also subclass models, and see how you are using your custom layers here. Instead of a weight, you are using an entire layer inside of this model. And the similar approach, in the init you make your custom layers, in the call you call your custom layers to make the computations work. And that is how you can achieve power into your entire workflow. So I'm not going to go into this slide a lot, but you can also have a bunch of other things like a train step, test step, predict step, fit step to extend your workflows even more. But essentially, if you're starting off with Keras, you need the sequential API. If you want something more flexible, you need the functional API. If you want more power, you need the model subclassing and the layer subclassing API. So simple, flexible, powerful, we have achieved the Keras philosophy. Now, a little case study that I always like to share with the folks that I'm currently talking to is simple things should be simple, complex things should be possible, and where we, as in me and Ritvik, were really happy to focus on complex things should be possible is with a little case study that we did, and also something called as nerves. So what happens here, what is happening here, it might look a little intimidating, but we also have a Keras tutorial around this. So go to keras.io, you have an example around this. What we are doing basically is to build a neural radiance field model with Keras in under, I'm not sure about this, so don't quote me on this, but in under 500 lines of code, which is kind of crazy to think about. So a NERF model, if you go and search for NERF in archive, you get a bunch of papers. What we did was show how you can achieve this model in Keras in under 500 lines of code. So you can see that the predicted image is quite nice. You get a geometric image. You also get the depth maps. You also see that the loss plot is going down. So anything that is complex should not necessarily be complex, but it should be possible. And that is what we show with Keras. So that's a case study. And now something on a personal note. So I was fortunate enough to work on a Keras product that was recently released. And we are going to talk about that. And after that, I'm going to take a bunch of questions if you have some. So let's go back to the slides where we understood what deep learning was. So what deep learning is nothing but matrix manipulation. So you have a bunch of weights. These are 2D matrices, 3D matrices, 4D matrices, whatnot. A bunch of biases. These are vectors. And you have your inputs, which are in numeric form. That is, you have matrix of images. That is, if you consider an image to be of height, width, and channel dimension. So you have H cross W cross C matrix, which you need to multiply with your weights, and you need to add with your biases. So everything boils down to matrix manipulation. What you also need is a strategy to update your weights and biases. So you need automatic differentiation. And automatic differentiation can be achieved with TensorFlow's gradient tape, with PyTorch's gradient API, with JAX's grad API. And now comes a little tricky question. Keras does not have an automatic differentiation. It was always using tf.gradient tape. If you have to create something on your own, you have to use TensorFlow.gradient tape. But why not use torch.gradient or jax.grad for that matter, and use Keras as a user interface to deep learning in the true sense of the term? Enter Keras Core. So this is something that I was fortunate enough to work on with the Keras team. So in Keras Core, what it is in maybe 4 points is a full rewrite of Keras. So we do not have a dependency on TensorFlow anymore. Keras can work with PyTorch, with JAX, with TensorFlow. There is no technical debt, as in you don't have to necessarily understand TensorFlow to come to Keras. You just have to understand how Keras works. And Keras will take care of all the debts that you have accumulated over the years with NumPy, PyTorch, TensorFlow, and JAX. It's much smaller code base, and it's not me who is saying it, it's Francois who is saying it. We'll come to that in a later slide. It also supports multi-backend. I just cannot blabber much, and I'm smiling. This is just me being excited about how big this is. So JAX, TensorFlow, PyTorch, and even NumPy can all work as backends to the new flavor of Keras. A drop-in replacement for TF Keras. So if you have been already working with Keras, and you already know what TensorFlow looks like, and you have a bunch of code base written with TensorFlow, you don't have to worry at all. tf.keras is just a drop-in replacement. I beg your pardon. Keras Core is a drop-in replacement for tf.keras. So if you have a lot of code already written, you just have to change your imports and everything works off the bat. And there are two sibling repositories that I currently contribute to. One is Keras NLP, one is Keras CV. As the name suggests, Keras NLP is Keras Natural Language Processing. Keras CV is Keras Computer Vision. So these two sibling repositories also take the help of Keras Core, which makes them backend agnostic as well. So if you have a PyTorch model, if you have a TensorFlow model, if you have a JAX model, you can seamlessly work with those models inside of NLP and CV without having to break a sweat. What is Keras Core? If you scan this QR, you're going to be taken or redirected to another blog post that me and Ritvik have written on PyMed Search. That is my company that I work for. And this covers what Keras is, what Keras Core is, and a little introduction to how you can, train a model with JAX as within 100 lines of code, I guess. So JAX is a powerful framework that we have currently been using a lot inside of PyMed Search, and we like it for its efficiency and JIT compatibility, XLA compatibility, and whatnot. So if you want to take a deeper dive into Keras Core, feel free to scan this, and you'll be taken to the free open sourced blog post. So let's talk about Keras Core a little more. It's a rewrite of Keras, as I said, and this is a tweet by Francois Cholet. He said that it was the code came from 135k lines of code to 43k lines of code, which is a huge, and when I say huge, there are like lots of U, lots of G, lots of E's into this huge that I say, huge, massive reduction into the lines of code. And who does not like lines being going down into a repository than going up? It's much better review process. It's much better to keep your sanity. And mostly what has gone down is the TensorFlow 1 version 1 technical debt, and that is what has helped us into making Keras backend agnostic. So a little, I think it's visible. If not, I'm going to share the slides after my talk, so don't have to fret about that. I'll be sharing this with the host as well as in my Twitter, so keep a look at that. What I'm trying to say here is that this is a script which talks about a model summary, model compile, model fit. So the data is already there. You create a model, you create the model's compilation process, you also train your model, and you evaluate it and predict it. And this is one script that works, right? Now, what happens with Keras Core is that you can use this script to work on any backends that you want. So if it's TensorFlow, it works. If it's JAX, it works. If it's PyTorch, it just works. So what I'm trying to get to is, again, backend agnostic. If you like working with a lot of backends, Keras Core has your back. And as I said, it's a drop-in replacement for TensorFlow. So people who already are smirking that, hey, you were talking about TensorFlow like 2 days or 3 days back. See how Keras has deprecated TensorFlow? It has not. So if you have TensorFlow, don't have to worry about anything. It just works off the bat. You have to replace your import from TensorFlow import Keras to import Keras Core as Keras, and everything works. Seamless switching. This is something which is my favorite. So if you have a script and you have PyTorch installed on your system and you don't want to install TensorFlow, you don't want to install JAX, you just have to initiate this environmental variable called Keras backend to Torch, and everything works. You can also initiate this Keras backend environment variable to JAX, to TensorFlow, and Keras Core takes this environment variable and understands that the user is trying to use TensorFlow, it's trying to use JAX, it's trying to use PyTorch. And we have Iron Man as TensorFlow for no biases at all. But it's just like you have different superheroes as your backends, and you can use any superhero that you want to save your city. So that's seamless switching. And coming to the advantages of Keras Core, for that matter, it supports cross-framework data pipelines as well. So what do I mean by data pipelines? tf.data is something which I have already touched upon, which I personally like a lot. So it gives you a lot of APIs to work with, like map, batch, shuffle, prefetch, ragged batch, and all that. So you can work with that. If you come from a PyTorch background, you have already understood, and you have a lot of understanding about Torch utils data loader. So if you don't want to learn a new data pipeline, that is tf.data.dataset, Keras Core has your back again. So you just have to initiate a data loading process. You have to write your iteration pipelines, and your model just works with the data that it kind of ingests from the data loader. NumPy arrays work with this entire pipeline as well. Pandas data frames are something which we also work with. Pi datasets is something which I haven't personally worked with as of yet, but I wish to be working with it in the near future. But that's also covered. Talking about your entire script or the deep learning paradigm, you need pre-trained models in 2023. You can't just learn everything or train everything from scratch. You need huge pre-trained models which you want to fine tune your specific or custom data sets on, right? And with that comes in Keras NLP and Keras CV. So for example, you don't want to train a model with maybe 100 to 300 images that you have. That's a custom data set, and a deep learning model for that matter is not going to learn much from just a mere 100 to 300 images. What you're going to do is you're going to use a pre-trained, that is that a trained model which has already been pre-trained, that is trained previously, and you're going to use that model with better weights and biases, and you're going to train that or fine tune it on your custom 100 to 300 images, and it's going to give you good performance. So like Keras CV, which is computer vision oriented, NLP, which is natural language processing oriented, also has a bunch of pre-trained models that you can use off the bat. This point is something which I also wanted to talk about, which is progressive disclosure of complexity. And this is not only the philosophy of Keras, this is also something which I personally use in my day-to-day. So while teaching, what I try doing is to disclose complexity in a very step-by-step manner. So think about where we were and where we came to. We were at the starting of deep learning. Deep learning is nothing but matrix manipulation. Deep learning also needs your calculus from high school, or maybe calculus, whatever you are learning right now, that is gradient optimization. After that, we talked about abstracting this entire thing into an automatic differentiation engine like tf.gradient tape or torch.gradient, jax.grad, and how you can harness everything inside of Keras. So progressive disclosure of complexity is something which I have already used in my slides. If I can use something, some topic or idea inside my slides, why can't you use that inside of Keras Core? And Keras Core does exactly that. You start simple with sequential API. You customize as your needs. So you are kind of disclosing a little more complexity with the functional API. And now once you need a lot of complexity inside of your code and you understand what you are doing to the word T of your entire paradigm or deep learning pipeline, you go into your subclassing of layers and models. So that's what progressive disclosure of complexity helps you do. And it also introduces a new stateless API for pure functional programming. So people who already know about JAX, I don't need to tell you what I mean by pure functional programming. But people who are unaware of JAX or don't know what pure functional programming is, it's a paradigm like object-oriented programming. But in object-oriented programming, you have states inside of these objects, right? You define your states. But in pure functional programming, you don't have these states. So you have to pass your states through inputs, and the function modifies your states and returns your states as outputs. So any side effect that happens to your states are not going to happen inside of pure functional programming. And JAX profusely tells you that pure functional programming is something that you need. And Keras Core, due to the fact that Keras Core already supports JAX, you need to have a stateless API, which is something which a bunch of people have worked on. And it's kind of crazy to see how Keras was OOP, but now it's very pure functional. It also agrees to pure functional programming paradigm, and it just works very nicely. So with that, I come to the last, but I think in 2023, it's one of the biggest things that people need is distributed training. So what do you mean by distributed training, Aritra? So you have a model, you have a GPU. You fit that model into a GPU, you train the model, and it works. But now you have a bigger model and the GPU is too small. You need your model to train distributedly, or maybe you have a model and you want a lot of data to get ingested. So both of the places, you need your model to be at different servers, different GPUs, and it trains differently on different systems, but it trains together. So that is a distributed training paradigm. And Keras Core helps you with distributed training as well. It's as easy as non-distributed training. So with JAX's PMAP, Torch's distributed data parallel, and TensorFlow's TF.distribute APIs, you can harness all of this inside of Keras Core. So with that, I come to the end of my slides. A little bit about the references and acknowledgements. So code examples, that is keras.io code examples, are something which I have already contributed to, and I love seeing a lot of contributions from the community. About Keras is a guide that that I have profusely seen, and am also referring to a bunch of people who are new to Keras and what Keras Core is all about. Developer guides is something which you can also go to. But the last one, that is Notes to Myself on Software Engineering, is a Medium blog post written by François Chollet, and he covers what software engineering as a paradigm is. And once somebody who wants to go into a software engineering world, uh, once you read through the entire blog post, you will get to understand that a lot of Keras philosophy comes from this man himself. He thought about the API to an extent where he wanted everyone to enjoy rather than just get through with it. He wants to enjoy us using Keras. He wants to understand what are the pain points of using Keras and how can you make deep learning or deep learning engineers' lives easier. So I thoroughly plead you, for the lack of a better word, plead you to go through the Notes to Myself, if not the three, but definitely the last one. And it's a very easy read. Just read it once you're free. It's a 15-minute read, I guess, and you will be able to understand what I'm trying to talk about. And again, a Q2 PyMet search if anybody wants to know what we do, know what our blog posts are like, know what our teaching strategies are, and bunch of other things. If you want to do that, that's it. And just a dot summary, and this is a little subtle hint of if you understand Keras, you already have understood why this is dot summary in parentheses. Dot summary tells you a summary of the entire model that you create in Keras. So as a Keras lover, the summary would be why do we need Keras? And I hope with this talk I was able to convince at least one in the audience to come to the Keras world, see how we do things, see how the community is. The Keras philosophy, so simple, flexible, and powerful. Easy extensibility, where we can extend anything into maybe a new layer, new model, new metric, new callback, and whatnot. A little case study that I liked. So NERF. And that's it. That's it from my end. Thank you for having me. Any questions from your end?
So thank you very much, Aritra, for the well-written and both informative presentation. I guess some of the guys from the auditorium are beginners and also like progressing people in the field of deep learning, and they got so much like insights and information about the Keras philosophy and your experience as well. So I guess there might be some questions from the audience. So we could transfer the mic to the people who have questions. Maybe the questions about the Aritra, because he has so much experience in the field of deep learning.
Sure.
Is it working? Is everything all right? Can you hear me? so we can ask personal questions too, right? Not personal, but regarding your
Yeah,
work.
sure. Sure.
I
That's
was
great.
really interested how you got to the Keras Core team, because uh, open source for me and maybe for a lot of students at universities, it seems like Wild West, because we don't really know how to get there. What are the job
Mhm.
prospects? How did you
Mhm.
get there?
Okay, so that's a great question, by the way. I'm very big on open source contributions, and I would love for everybody to not consider this to be Wild West and come start contributing. So my first and only one-liner to open source contribution is understand a repository which you love. And this might come as an advice which you have already heard, but I'm going to share something which is a little personal. So the first time I contributed to a open source repository was for a company called Weights and Biases, and I used to love their product. And I had gone to an extent where just wanted to understand how this works. I didn't have a lot of background in Python. I didn't have a lot of background in deep learning. I didn't have a lot of background in machine learning, but I just had completed my undergrad and was looking forward to understanding how software works. And with that sense of curiosity and sticking to one thing and one thing only helped me a lot into into building a determination of, okay, hey, I have to do it. I have to understand what comes where, what is it that I need to do, and maybe not start with a PR, maybe not start with a pull request, just start with an issue that you find interesting. You will find a lot of beginner issues that anybody can tackle. But if you think you are not, how do I say it, if you are not capable enough to answer the issue, there are going to be people who will help you. So nobody is born with a lot of software engineering skills. They build on top of what you have, and also from constructive criticisms. So if you have a community around you, like Keras has a brilliant community, and I can't talk much about it, like because it's going to end the entire question answer session. But the Keras community is really great. I got to learn a lot from Keras, and how I got into Keras Core was due to my contributions to not only Keras but also Keras IO examples. And Francois himself had reached out to me saying, hey, do you want to contribute to an interesting product that we are currently working on? And I could not say a no to him. So that is how it works. But for you folks who are young and are trying to get into open source, stick to one repository for maybe 1 month, 3 months, 6 months, whatever. If you like it, you are going to have you will have answers to some issues, and just type it out. Don't think about whether it's being too rude, too noob for that matter, too pro or whatever. Just type it out. There will be people who will guide you throughout your process. So just don't, you just have to break that barrier and get into the issues and PR. So that's going to be my one advice.
Okay, thank you. So if there are no other questions, can I ask another question too? It's a more technical one. It's
Mhm.
about JAX. So
Okay.
I heard about JAX about 3 to 4 months ago.
Mhm.
There is a YouTuber, Alexa Gordic. He works
Yes.
at Microsoft Research, and he has
Mhm.
this playlist on JAX. And I don't really understand.
Okay.
JAX is also from Google, right? The development
Yes.
team is also from
Mhm.
Google.
Right.
What was the what's the purpose of having two different AutoDiff engines, JAX and TensorFlow, in Google?
That's again a great question. So it's not about why you need to. It's more about um, the two thought processes of having two different automatic differentiation engines. So think about JAX to be a pure state, pure functional programming paradigm that helps you with your state management. That is something which is really important in deep learning, wherein you cannot have weights and biases that are affected by different layers. You can't have them do a bunch of side effects for some other computations. You have to have very pure states throughout your deep learning, and that is where JAX helps a lot. There is this other thing that I also like about JAX is its compatibility with XLA. So JAX is hardware agnostic. What I mean by hardware agnostic is the same code that you write in JAX can work on CPUs, it can work on GPUs, it can work on Google TPUs as well. How do they do that? That is due to something that JAX calls LAX, which is jax.lax. So everything that you see in JAX, that is jax.numpy.something, jax.nn.something, all these APIs are basically boiled down to this lax API, which helps you. And funny how lax is an anagram to XLA. So this lax API helps everything that is written in JAX get compiled into these hardwares right off the bat. So as I am not a Googler, so I can't help you with more details as to why there are two autograd differentiation engines. But my main focus was with JAX, you have this immense power of low level code. With TensorFlow, you can in fact do low level code, but there are a bunch of problems that the gradient tape has, that is the tf.gradient tape has. Very simple, that is coming right on top of my head, a problem that TensorFlow does not allow you to is multiple differentiation. So if you need a first order derivative, tf.gradient tape works. If you need a second order derivative, you need to nest the tf.gradient tape scope inside of another tf.gradient tape scope. And think about a third order derivative. It goes on, right? But with JAX, what happens is you just have to call a jax.grad on top of jax.grad on top of jax.grad. And due to the fact that it's all functions, you don't have to nest them and then again de-nest them. You just have a function that is doing your third order derivative right off the bat, which makes it very easy to do maybe physics simulations, to do deep learning with flow models and whatnot. So those are like the main pointers that you need to understand while you talk about JAX. TensorFlow and JAX are two different perspectives altogether. That is what Google tries to come up with.
Okay, thank you. It's a really, really good answer. Thank you. I didn't
Not a
really
problem.
expect such technical things. These multiple derivatives are really helpful, I think. I should check it out more.
Sure. We
Mhm.
also, okay, so this is going to be a segue into another little PyMed search thing. We have a blog post around, if I'm not wrong, around JAX, and I'm going to share it. Just a second. I'm going to share it in the chat with you folks. If you like it, do link it to your YouTube stream, which is live right now. People can get into that. But what me and Ritvik did is not only cover JAX as a deep learning framework, but also understand where JAX comes from. So it comes from AutoGrad and also NumPy. Both of them together get down to this pure functional state paradigm and all that. And this blog post was also reviewed by the JAX team. So it's Bible for us.
Okay, great. Thank you very much.
problem.
Does anyone else? Yeah, could you transfer the mic?
Hello.
Hello.
It was a very nice talk. Thank you very
Thank you
much.
so much.
And also, maybe completely not like out of the blue. What do you think about Kaggle? Do you use it as much? Because I'm
Okay.
just getting into this world, and I wanted to know what do you think about it.
Okay, so I do use Kaggle. I'm not a Kaggle grandmaster, notebook master, anything. I like Kaggle for maybe I'm not equipped to answer this as of yet, but what I like about Kaggle is a bunch of data that you can work on. So what you can do due to the fact that you are starting with Kaggle, you can go into discussions. You can see the already discussed competitions answers or maybe solutions as to how people have worked on a particular problem. once you get into reading a lot of Kaggle competition notebooks, you will understand that the entire world of deep learning does not revolve around how well your model does, but also around how you approach a problem. That's something which people don't understand as of yet. Like, people who are beginning, they just think, hey, it's really intimidating getting started with deep learning because there are a bunch of research papers, there are a bunch of mathematical notations that we have got to kind of understand. But that's not it. You also have to have this appetite for thinking differently. If you think like a grandmaster, Kaggle grandmaster, you will be able to understand that things are really boiling down to like simple things. So, as my talk said, deep learning is nothing but data manipulation. This comes only when you understand, or you have gone through a lot of, uh, you have experienced a lot of code, you have experienced a lot of research papers and whatnot. So, my advice for you would be to definitely use Kaggle a lot, read a lot of discussions, read a lot of competition, already solved competitions, and also enroll in competitions, and maybe team up with people. And I can't stress on this more. Teaming up with good peers, and peers who are better than you or maybe worse than you just want to collaborate, do that, and that will help you progress a lot quicker. So I think that helps in any way.
Thank you so much.
No
That's it
problem.
for my question.
So does anyone else have any questions?
Hello.
Hello.
Actually, I am personal beginner in deep learning, and I'm learning for myself, and it becomes sometimes too theoretical. And I want to ask you some advice how to get like practical use of like deep learning, how to start like getting practical experience.
Right. So that's a good question again. I am blown by the quality of questions, firstly. Really good questions. So my advice would be to, if you think you want a practical application of deep learning, you might just come up with an idea and start working on it. I won't say it's going to fail or it's going to get successfully done. I just want you to get started with something. What that does is, you now are against a wall, which is your failure. So what that does is lets you build up your confidence into understanding what theory does, because you can only achieve your practical goals to an extent where you understand your theory. You just don't or will not be able to understand a particular API in Keras or maybe in deep learning, say for example a convolutional neural network. You have to read a little bit to implement it, or you have to read a little bit to understand where you want to implement it. So once you have this vicious cycle going on for yourself, where you are not only trying on your code but also reading a little, trying on your code, reading a little, only then can you break away from this intimidating factor as to this is getting too theoretical, I just don't want to read anymore. So start with something very small. Build a image classifier, for that matter, wherein you have an image and you just classify whether it has a cat or a dog. But start somewhere and take a bunch of help from practical blogs and not your theoretical books. Once you have something running and you share it with your bunch of friends, and your friends are really excited that, hey, that's great, this is great, I am using this with your application, that with your application, you will have an urge to work on that application a little bit more. And that is when you start building your theory as well. Does that make sense, or am I blabbering a lot?
Yes, thank you. It makes sense.
No problem.
We'll
Thank you
work
so
on
much.
that. Thank you.
So thank you very much for the question. Does anyone else have any question? Okay, I guess we are out of time. Thank you very much for investing your time to be the guest speaker of our first GDSC event at Nazarbayev University in this semester. So I guess many of us did get some practical and both theoretical insights about how Keras works, what's the philosophy of Keras, and I guess some of us were really inspired to get in the field of deep learning by your presentation. So thank you very much, Aritra, again. Thank you very much for our viewers on the stream.
Thank you so
Yeah,
much.
I guess
Yeah.
we will close here. Bye.
Sure. Bye-bye.